Hello everyone. So in continuation to our quantitative aptitude, our next topic will be calendars. Generally in this topic calendars, they may be giving us a date in a particular year, in a particular month, and they may ask us to find out the day of that or any question related to finding out the day. Questions will be like that. So for that, first we will have this information with us, means we need to remember these particular days for the last year of each of the century. For example, last year of year 1600 will be Sunday. So 1600, 1700, 1800, 1900, 2000, like this we will write, and we can start with Sunday, end with Sunday. Then 1700 we will just go one day we will leave it, means alternative previous day, in the sense Sunday, the previous day is Saturday, we'll skip that, and then Friday. Similarly, Friday's previous day is Thursday, we'll skip that, and then Wednesday. Then previous day to Wednesday is Tuesday, we'll skip that, and then Monday. Even if we want the last day of the subsequent years, that is 2100 or 2200, etc., it will be in this order only. Similarly, the previous centuries also will be in the same order, in the sense previous, that is 1500 will be Monday, 1400 will be Wednesday, like that. This we will remember. Now let us understand what do we mean by an odd day. When we consider a normal year, or we will say non-leap year, or we will call it as ordinary year, it will have 365 days. And if we convert it into weeks, we will have 52 weeks. And 52 weeks, if we calculate, it is 52 into 7, we get 364 days. That means that one day we call it as odd day. Then in a leap year, since we have 366 days, that will be splitted into 364 days, that is 52 weeks. And here we will have 2 odd days, means a leap year will have 2 odd days, and non-leap year or ordinary year will have 1 odd day. So this much of information we will have to remember. Let us proceed to the questions to solve. What was the day of the week on 16th July 1776? So the very first step is we will consider the year, that is 76. We will consider 1 less, means we will write 75, 76 minus 1, 75. Then we will understand how many leap years are there in the past 75 years. So that can be done by dividing 75 by 4. 4 ones are 4, 35, 4 eights are 32. We will have to consider the quotient, which means that in the last 75 years, there are 18 leap years. Why we do this? To understand how many odd days. So for all the 75 years, we took 1 odd day, but for leap year, actually it should be 2 odd days. That is why we are adding the number of leap years, so that automatically those 2 odd days are considered. Then this particular century, 1700, from there till 75, means 1701 to 75, we have, for this 1776, the first month, which is January month, it will have 31 days. Then we will consider this 76, is it a leap year or not? If it is a leap year, it has to be divisible by 4. We will see 4 ones are 4, 3, 6, 9. Remainder is 0, so it is a leap year. Since it is a leap year, February will have 29 days. March will have 31 days. April will have 30 days. May will have 31 days. June will have 30 days. And July, since this particular date is also given in the month of July, so we will consider 16 days in that. Now, let us divide each of them by 7. If I divide this by 7, 75. 7 tens are 70. So remainder is 5, which means 5 odd days we can consider. Here, if I divide it by 7, 7 twos are 14. So 4 is the remainder. Here, 7 fours are 28. Remainder is 3. Here, remainder is 1, 3. Remainder is 2, 3. Remainder is 2. 7 twos are 14. Remainder is 2. Now, wherever 7 is there, I mean the sum, we can consider it as 0. So here, 5 plus 2 means this one. This is 7, so we can consider it as 0. 5 plus 2 means these two. We can consider it as together as 0. And then these together will become 4, which means the final remainder means instead of adding all these things, we are dividing everything by 7. Otherwise, we have to add all these things and then divide by 7 and find out the remainder. Instead of that, we are individually doing to find out the remainder. Remainder is 0. Sorry, remainder is 4. Final remainder is 4. Now, we know for 1700, the last day of the year of 1700 is Friday, which means we need to now add from Friday 4 days, 4 odd days, which means it is Saturday, Sunday, Monday, Tuesday. So we get the day as Tuesday. That is the solution for this question. Let us move on to the next. So here, sorry, I wrote it there. We should do it here. Friday plus 4, we get Tuesday. That is the solution for this. Let us move on to the second question. On what dates in May 2002 did Monday fall? So for that, we will consider finding the day on 1st May 2002. This is 2. So less 1, we get 1. Then number of leap years, of course, if I divide 1 by 4, it is quotient is 0. Then January has 31 days. February, this is not a leap year. So February will have 28 days. March will have 31 days. And then April will have 30 days. And here it is 1st May, so I will simply add 1. Now, this 1, we will keep it as it is. 31, if I divide by 7, remainder is 3. Remainder is 0. Remainder is 3. Together, remainder is 3. So now 3 plus 3, 6, 6 plus 3, sorry, here together, 6 plus 1, it is 0. We can put 0. So remainder is 3. Remainder is 3. And 2000 century, we may notice what is the day, last day of the year. It is Sunday. So Sunday plus 3, we have to add. So it becomes Monday, Tuesday, Wednesday. So Sunday plus 3 is Wednesday. Means Wednesday is the day on 1st May 2002. Which means Monday, which will be the Monday, 2nd May will be Thursday. 3rd, Friday. Then Saturday. then Sunday, then Monday. This is 4th, this is 5th, Monday is 6th. So therefore, our question is on what dates? So it will be 6th and then add 7, 13th, add 7, 20th, sorry. 27th or Mondays in May 2002. That will be the solution. Let us move on to the next question. Radha celebrated her wedding anniversary on Tuesday, 30th September 1997. When will she celebrate her next wedding anniversary on the same day? So now, year 1998, number of odd days. Year 1998 is a non-leap year, so it is 1. 1998 will also be 1. 2000, it is a leap year, so you will have number of odd days 2. Then 2001, 1 odd day. 2002, 2 odd days. 2003, 1. So we need to do this till we get a 7. Here it is 4, 5, 2. Sorry, 2002, 1 only. Sorry. So this totaling to 7, 4 plus 3, 7. So therefore, 1997 plus 6, we get 2003. So therefore, in the year 2003, she will celebrate on the same day. Means the same day will come after 6 odd days. Okay, let us move on to the next question. If today is Monday, then after 30 days, what day it will be? So 30, we will be dividing it by 7 to find out the remainder. 7 fours are 28. Remainder is 2. Therefore, after 30 days, the day will be Monday plus 2. Means it becomes Wednesday. Let us move on to the next question. January 4th, 2006 falls on Monday. What day of the week does January 4th, 2007 lie? So it is given Jan 4, 2016 as Monday, and 2016 is a leap year. So I need to add 2 days to get Tuesday, Wednesday, which means Jan 4th, 2017 will be a Wednesday. That will be the solution for this. Let us move on to the next one. 1st March 2006 falls on Wednesday. What day does 1st March 2010 fall? So 2007, 1 odd day. 2008, it is leap year, so 2 odd days. 2009, 1 odd day. And it is coming on March 1st, 2010. So 2010 is again a non-leap year, 1 odd day. Total is 5. So therefore, 1st March 2010 will fall on Wednesday plus 5, which we will get Thursday, Friday, Saturday, Sunday, Monday. That is the solution. Let us move on to the next. If 8th March 2006 is Wednesday, then what was the day of 8th March 2005? So they gave us 8th March 2006 as Wednesday. Both 2006 and 2005 are non-leap year. So when we go back, we have to subtract one odd day, which means Tuesday will be our 8th March 2005. So that is the solution for this particular question. What was the day on 25th of September 1967? Last 2 digits 67, 1 less means 66. Then how many leap years are there in the last 66 years? Let us divide it by 4. 4 ones are 4, 26. 4 6 are 24. So remainder is 2. Quotient is 16. So 16 leap years are there. Plus number of days in January, number of days in February. This is a non-leap year, so 28. March 31 days. April 30 days. May 31. June 30. July 31, August 31, September 25. So 7, if I divide, 7 9s are 63, so remainder is 3. 7 2s are 14, remainder is 2. 7 4s are 28, remainder is 3. This is 0, this will be 3. This is 7 4s are 28, remainder is 2. Here remainder is 3, remainder is 2, remainder is 3, remainder is 3. 7 3s are 21, remainder is 4. Together this is 7, so 0. Now this is together 7, so it is 0. Here this is 5, this is 6, this is 3. If I add now 5 plus 6, 11. This is together 3. So 11 plus 3 is 14. So remainder is 0. And in the last day of this century, means 1900 century last day is Monday. So Monday plus 0, it will be Monday only, which means that 25th September 1967 is a Monday. Monday is the date of 25th, sorry. September 1967. That is the solution for this.